Okay, today we're going to talk about solving quadratic equations, and we're going to do that by completing the square. Now, I'm going to start off with a fact. The fact is that if a times b is equal to 0, then either a equals 0 or b equals 0, or both. We're going to use this fact several times while we solve quadratic equations. So just keep it in the back of your mind that we're going to be using this fact. So let's say that we've been asked to solve x squared plus 7x plus 12. I think a lot of us can already see that this is actually equal to x plus 3 times x plus 4. And on the right, we don't do anything. It's still just equal to 0. So this one is easily factorable. And hey, look at this. We have a product that's equal to 0, which means that one of its factors must be equal to 0. In other words, x plus 3 is equal to 0, or x plus 4 is equal to 0. In other words, x is equal to negative 3, or x is equal to negative 4. We can write this in several ways. We could say that the solution is x must be in the set negative 3, negative 4, or we can write x equals negative 3 or x equals negative 4. Either of those is completely fine. Okay, so here you can see that I have graphed the equation x squared plus 7x plus 12. You'll notice that we have some key points here. The x-intercepts are negative 4 and negative 3. Those correspond with the solution to our equation because that is exactly where our function is equal to 0. X squared plus 7x plus 12 is equal to 0 when x is equal to negative 3 or x is equal to negative 4. That corresponds exactly with this graph. The graph of x squared plus 7x plus 12 is equal to 0. That actually is exactly what it means when we're talking about x-intercepts. When is this function equal to 0? Well, it's equal to 0 when x equals negative 4 or x equals negative 3. There's a direct correlation between these two things. In the last video, we looked at completing the square, and it turns out that completing the square is a great way to solve quadratic equations. Let's complete this square to see what happens. The first step for completing a square is to factor out any kind of coefficient on x squared. So in other words, we don't want any leading coefficient that's not 1 when we're completing the square. Keep in mind this is going to introduce some fractions, so just make sure that you're comfortable adding and subtracting fractions. The leading coefficient in this question is negative 2, so that's what we're going to factor out. So I'm going to factor out a negative 2, and I'm left with x squared plus 3 over 2x minus 7 over 2. That's still all equal to 0. Don't forget to write equals 0 at each step. Next up, let's complete the square. So I'm going to write that this is equal to, well, negative 2 times x squared plus 3 over 2x. Now what I have to do is take 3 over 2 and divide that by 2 and square all of that. So that's equal to 3/4 squared, which is equal to 9/16. So I'm going to add and subtract 9/16 and see what happens. So I'll add 9/16 and subtract 9/16, and I've got still the negative 7 over 2. Great. Let's keep going. Oh, I forgot. This is still all equal to 0. Now I've got everything set up to complete the square. So I'm going to say, well, I want the square root of 9/16, which we already calculated. That's what this is. it's 3 over 4. So I'm going to have x plus 3 over 4 squared, and that's still in the brackets. Now that's what this portion is here. We still have to deal with this. So let's add these two fractions together, and let's see what I have. Well, I've got, if I multiply both of these by 4, then I'll have a common denominator. Oops, not 4, 8. Excuse me. So I'm going to multiply both of these by 8. So I'm going to have negative 9 minus 56 over 16. So 9 minus 56, or negative 9 minus 56, that is equal to negative 65. So I have minus 65 sixteenths. Still all equal to 0. Now, the nice thing about setting something equal to 0 is that if there's any common factor, you can just delete it. So essentially what I'm going to do is I'm going to multiply both sides of this equation by negative 1 over 2. So when I do that, I'll have negative 1 over 2 times this times negative 1 over 2. Obviously, 0 times negative 1 over 2 is still just 0. So I'm left with 0 on this side. And this negative 1/2 times negative 2 on the left, that cancels out. We get just 1. So altogether, we have x plus 3 over 4 squared minus 65 over 16 equals 0. We're almost done. Now we have, well, let's bring this 65 over 16 to the other side. So we're left with x plus 3 over 4 squared equals 65 over 16. Now we'll take the square root of both sides. Square root of both sides. Now one thing to remember is that when you take the square root, when you introduce that symbol, you will get a plus and a minus sign. Okay? So these square roots, they cancel with this power of 2. That's why we took the square root. And we're left with x plus 3 over 4 is equal to plus or minus the square root of 65 over 16. And that means that x is equal to negative 3 over 4 plus or minus the square root of 65 over 16. Now I'd like to clean this up a little bit. So let's keep writing this. So this is equal to x, so in other words, x is equal to negative 3 over 4 plus or minus. Well, the square root of 16 is 4, so I can actually just keep that square root symbol only on the numerator. So this is now going to be 65 over 4. And now we have a common denominator, so x is equal to negative 3 plus or minus the square root of 65 all divided by 4. Now, you might be asking yourself, well, why didn't we just factor it? When we factored it, it was so much easier. And the answer is because this would have been very hard to factor. So let's think about what would have been required to factor this. So I would have to multiply 7 times negative 2, so I would get negative 14. And I would want factors of negative 14 that add to negative 3. That's pretty hard to do. There's only so many factors of negative 14. We would have 1 and 14, 2 and 7. So that's not going to work out very well for us. So the reason why this still works is because these aren't whole numbers anymore. We've actually had to go into irrational numbers. So it would have been very difficult to find factors of factors of negative 14 whose product is negative 3. Now, you'll notice that we have this plus minus sign. That means that x is in the set negative 3 plus the square root of 65. Let me write that nicely. Square root of 65 over 4. And negative 3 minus the square root of 65 over 4. Now, these are our two solutions, which means that the product of these actually is equal to 7. And if you add them together, you will get -3. You don't believe me? Try it yourself. The thing is that when we're factoring, this would have been a very difficult set of numbers to find. It would pretty much be impossible to just keep guessing and checking. So we actually prefer to complete the square when these quadratic expressions get a little bit complicated.